Welcome back to the Science of SKB with Miss B. Part 3. Radiation. Radiation is the third way heat travels. Unlike conduction and convection, which both need matter to travel, radiation does not. Radiation can be transmitted in a vacuum or empty space as a wave. For example, in some electric lamps, radiation emitted as light by the filament travels across a vacuum in the glass bulb to get out. The electromagnetic spectrum is comprised of radio waves, microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays. To remember the order of the electromagnetic spectrum, the following acronym can be used. Raging Martians invaded Venus using X-ray guns. Each part of the electromagnetic spectrum affects us differently and behaves differently. For example, infrared radiation is responsible for heating us up, while visible light allows us to see colors and influences our sleep cycle. They are all transverse waves that travel at the same speed, 3 times 10 to the 8 meters per second. Radiation is how heat and light reach us from the sun, also mostly through a vacuum. Radiation travels as electromagnetic waves. Radiation is the flow of heat from one place to another by means of waves. Radiation is emitted by all bodies above absolute zero and consists mostly of infrared radiation, but light and ultraviolet radiation are also present if the body is very hot. The sun is an example of this. It emits lots of radiation. Radiation is also emitted by a fire or a flame. The heat you feel from a fire is infrared radiation, which is an electromagnetic wave. Good and bad absorbers of heat. Good absorbers of heat are metals and dark-colored bodies. Bad absorbers of heat are cotton, plastic, rubber, and shiny surfaces. Some surfaces also emit radiation better than others when they are hot. The cooling fins on the heat exchanger of a refrigerator are painted black so that they lose heat more quickly. In general, surfaces that are good absorbers of radiation are also good emitters when hot. Two factors other than color that affect the amount of radiation emitted per second by a surface are A, its area, and B, its temperature. Increasing either of these increases the radiation. Effective applications of radiation. Some effective applications of radiation are a vacuum flask, a glass house, and a solar water heater. Vacuum flasks are sealed within a vacuum case. This mechanism stops heat from radiating into or out of the flask. The inner flask is coated with a reflective surface that reflects radiation back into the food or liquid within the flask. The way the vacuum flask is manufactured is meant to keep food and liquids at the temperature the users wish it to be. The glasshouse effect. Light and short-wave infrared rays from the sun penetrate a glass house or greenhouse and are absorbed by the soil, plants, etc., raising their temperature. These in turn emit infrared radiation, but because of their relatively low temperature, this has a long wavelength and is not transmitted by the glass. The greenhouse thus acts as a heat trap and its temperature rises. Solar water heating. Solar water heating works by using a black absorbing surface called an absorber inside collectors to absorb solar radiation and transfer heat energy to water flowing through it. The heated water is then collected in an insulated tank, and the circulation of water from the tank through collectors and back to the tank continues automatically. The water that is heated by solar water heating is used for domestic, commercial, and industrial needs. Effects of carbon dioxide in the atmosphere. The presence of too much carbon dioxide in the atmosphere contributes to many things such as 1. Global warming, and 2. The acidification of large open bodies of water. Too much carbon dioxide in the atmosphere traps too much heat radiation on Earth. This causes icebergs to melt, which can cause serious floods. When we burn things like coal, oil, and gas, called fossil fuels, it releases a gas called carbon dioxide into the air. Some of this carbon dioxide goes up into the sky, and some of it dissolves into the ocean. When too much carbon dioxide gets into the ocean, it mixes with the water and makes a weak acid. This process is called ocean acidification. It changes the water's chemistry, making it harder for sea creatures like clams, snails, and corals to build their shells and skeletons. Corals are tiny animals that live in large groups and build colorful underwater homes called reefs. They have a special relationship with tiny plants that live inside them. These plants give corals their color and help feed them through photosynthesis. When the ocean gets too warm, often because of climate change, the corals get stressed and push out the tiny plants. Without those plants, the coral turns white. This is called coral bleaching. If the water doesn't cool down in time, the coral can die because it loses its main source of food. So, acidification makes it harder for corals to grow, and the warming causes them to bleach. Both are caused by too much pollution from human activity, and both hurt ocean life. Comprehension. What is radiation, and how many types of radiation are there? Radiation is a type of heat transfer that does not require matter to travel. There are 7 types of radiation. Comprehension. Which parts of the electromagnetic spectrum allows us to see colors and B. feel heat? List 2 sources of radiation. Infrared radiation allows us to experience heat, while visible light allows us to see in color. 2 sources of radiation are the sun and the fire or a flame. We feel the heat from a coal fire by convection, conduction, expansion, diffusion, or radiation. 3 cans of identical size and shape. 1 is painted matte black, 1 is dull white, and 1 is gloss white. The cans are filled with boiling water. In which can will the water cool most quickly? Give a reason. We feel the heat from a coal fire by radiation. The water will cool most quickly in the matte black can because the color black is a good absorber of heat and also a good emitter of heat. Why does radiation pass more readily into a glass house than out of it? Light and short wavelength infrared rays from the sun are able to penetrate a glass house or greenhouse, and they are absorbed by the soil, plants, etc., raising their temperature. These in turn emit infrared radiation, but because of their relatively low temperature, this has a long wavelength and is not transmitted by the glass. The greenhouse thus acts as a heat trap and its temperature rises. Comprehension. The Earth has been warmed by the radiation from the sun for millions of years, yet its average temperature has remained fairly steady. Why? The Earth's temperature has remained fairly steady because the energy it receives from the sun is balanced by an equal amount of energy radiating from space. This net flow of energy into and out of the Earth system is called Earth's energy budget. Why is the temperature less likely to fall on a cloudy night than on a clear one? Clouds behave like a blanket. Cloudy nights are usually warmer than clear nights because clouds trap heat emitted from the Earth's surface and re-emit it back towards the Earth. This is because clouds reflect and absorb long-wave radiation, which prevents too much cooling from occurring. In contrast, clear skies allow for the maximum release of long-wave radiation to space, resulting in colder nights. Comprehension. What are the effects of too much carbon dioxide in the atmosphere? Too much carbon dioxide in the atmosphere can cause many effects, including climate change. This can cause a rise in global temperatures. B. Ocean acidification. This can cause pH changes, causing the bleaching of coral reefs and the death of aquamarine life. C. Ecosystem disruption. This can cause the extinction of certain animals, which can cause an explosion population of another. D. Glacier and ice sheet loss. This can cause the flooding of territories that are already below sea level. And E. Water use efficiency change. The rise in carbon dioxide in water can make the water too acidic for consumption. And this ends part 3 and the final chapter of heat. Thanks for watching.